This lesson starts by talking about stretches of functions. So the graph of a function g of x is equal to a f of x, where a is greater than 0, is a vertical stretch or a vertical compression of the graph of f of x by a factor of a. So if the a, or if the number in front of the function, is bigger than 1, the graph is a vertical stretch. If the a, or the number in front of the function, is between 0 and 1, then the graph is a vertical compression. So we talked about this in depth in terms of quadratics, which is the example that I have below, but it does work for every single function. So what you can see in the picture here is our original function, the red function, that is just x squared. What you can also see is the blue function. So this is a stretch where a is bigger than 1. This particular example is 2x squared. So what you can see is that instead of my first point being here at 1, 1, my entire, I can't draw on here and I don't know why, my entire point has been multiplied by 2, or by my a value. So now it's at 2, 1. The green function is 0.5x squared, so this is a vertical compression. So my entire function has been multiplied by 0.5, which is why that is at 1, 0.5. The graph of the function g of x is equal to f of k of x, where k is greater than 0, is a horizontal stretch or a horizontal compression of the graph of f of x by a factor of 1 over k. So what you're going to notice is that now we're talking about k, and it's going to be inside of my function. So the a was always outside of my base function. So you would see a number followed by your base function. Now, when we're dealing with k, or a horizontal stretch, we're going to be dealing with the values inside combined with our functions. So this is a little bit backwards. If k is bigger than 1, the graph is a horizontal compression. So this is a total opposite of vertical stretch and vertical compression. If k is between 0 and 1, the graph is a horizontal stretch. Now both of these are going to be by a factor of 1 over k. I'm going to explain in depth using the example below. So the first thing that you're going to notice is that my original function is square root x. So this is the red function that we see here. We know that we have those key points. So we have that point at 1, 1, we have that point at 4, 2, and we have that point at 9, 3. So those are, and 0, 0. Those are the key points that we learned about when we were talking about the base functions. When we're talking about an a value, or a vertical stretch or compression, we were taking the y value of those points and we were multiplying that. Now that we're talking about k, our horizontal compression or horizontal stretch, we're dealing with the x values. X horizontal probably makes sense since we know that the x-axis is the horizontal. We're going to take a look at the blue function first. It looks kind of purple on the graph, but f of x is equal to the square root of 2x. So I know that my k is 2, which means that I need to be multiplying all of the x components of these key points in my original function by 1 over k. So if my k value is 2, I need to be multiplying by 1 over 2. That means that this red point that I had at 1, 1 is now going to be at 1/2, 1. The second key point that I had at 4, 2 is now going to be at 2, 2. All of the x values need to be multiplied by a half, or cut in half. The third and final point that I had at 9, 3 is now going to be at 4.5, 3. We're going to be doing the exact same thing for this black function right here. So I could see that I have a k value of 1/2, which means that I'm going to need to be multiplying by 1 over 1/2, which is 1 over 1 times the flip, so times 2 over 1. So multiplying by 2. So now that 1, 1 is now going to become a 2, 1. And now the 4, 2 is now going to become an 8, 2. So all of the x values get multiplied by this 1 over k. All of these transformations will work for any of the base functions that I gave you. This is why it is so very important that you have these key points memorized. Otherwise, it would be very difficult for you to graph any of these other functions. Our first example says, given the function f of x equals root x, write equations to represent g of x and h of x and describe the transformations. So I'm just going to begin right here by saying that g of x is equal to 2f of x. So the first thing that I need to do is write my equation. So I know that I need to take this f of x function that I have up here, and I need to involve this 2 that I have. So right away, I see a 2 outside of my function, before my f of x. So right away, I know that that makes my a value 2. So I'm going to be able to start writing my new function. So g of x is equal to 2 root x. So I kept my 2 and I plugged in my f of x, which is root x. Now I need to be talking about the transformations that are taking place here. Since I know that my a is 2, I know that there is a vertical stretch or compression going on. Since it's bigger than 1, I know that this is a vertical stretch by a factor of 2. The next part of this example is the h of x that they were talking about in the question. So h of x is equal to 1/2 f of x. So again, the first thing that I see is that I have a 1/2 out front. That means that my a is equal to 1/2. If I'm writing my function out, I have, not a g anymore, sorry, h of x is equal to 1/2 root x. So I kept my 1/2 and I plugged my f of x in, which was in the question root x. Now I can see that I need to write my transformations. If a is equal to 1/2, I know that a tells me it's vertical. The 1/2 tells me that it is a compression by a factor of 1/2. Now, if I was thinking about graphing these, I'm just going to do a really, really quick sketch right here. I'm going to have my original function. So my original function is square root of x. And if I need to vertically stretch this, all of my y components need to be multiplied by 2. So now my 1, 1 is going to be at 1, 2. And my 4, 2 is going to be at 4, 4. So already I could see my new function. Same thing with this function. I'm going to have my original function right here, and I am going to be vertically compressing this function. So I am vertically squishing it. So my 1, 1 is going to be at 1, 1/2, and my 4, 2 is going to be at 4, 1. So my new function will look like that. We're going to be continuing on, so I just rewrote f of x is equal to the square root of x just because it's on a different slide and I wanted to make sure you remembered. So part C says g of x is equal to f of 2x. So before, the 2 was out front. We know that that was an a. Now that the 2 is in the brackets with the x, or in the f of x, we know that this is now a k. So k is equal to 2. So this does change how things look. So when I'm rewriting my g of x is now equal to the square root of 2x. So what this is saying is that I'm taking my f of x function, except wherever I see an x, I'm replacing it with 2x. Now from here, since I know that this is a k, I know that this is a horizontal, I need to figure out if it's a stretch or compression. So typically, we would think 2 would be a stretch, but since it's horizontal, it's backwards. So we know that this is a horizontal compression by a factor of, now remember, when we're dealing with horizontal compressions, it's always 1 over k. So it's 1/2. Part D says h of x is equal to f of 1/2 x. So again, we're seeing that this is in my function. This is with the x. This is a k of 1/2. So this means that h of x is equal to the square root of 1/2 x. Now, we know that this is a k. We know that this is a horizontal. Normally, a half would be a compression. K's are backwards, so this is a horizontal stretch by a factor of, now, it's 1 over k. I'm going to have to do a little bit of math here. 1 over 1/2 is the same as 1 times the flip of that bottom fraction, so 2.